Hello, welcome to everyone in this video. This is our lecture number 4 for the solution of the quantum mechanics, right? So, in the two lecture series, we discussed the question asked in uh, SN course quantum mechanics, and the lecture number 3, and this is the 4 in which we discuss the question asked in this book, that is the quantum mechanics by A.B. Gupta. So if you want to watch the previous lecture, you can go through the description box, link are given there. In this video, I want to discuss question number 10 to 18 of chapter 1, which consists quantum mechanics fundamentals of this book, that is quantum mechanics by A.B. Gupta. This is the part 2 of this book and the lecture 4 of this problem solution of quantum mechanics. If you want to watch the theoretical part and the others part of the physics, you can go through the description box, link are given there in separately. So let's start with question number 10, which says the long wavelength limit at which radiation is just able to eject photoelectron from the titanium is this. This is the long wavelength, that is my minimum energy frequency, that is the minimum energy, right? Long wavelength mean the short frequency, that means lower energy. Find the kinetic energy that must be imparted to an electron so that jump escape from the metal. So this is the minimum energy or the maximum wavelength which is required to escape the electron from the metal to its surface, which is known as the work function. So you need to find out this wavelength in terms of energy. So this is the wavelength. So energy is h nu, that is hc by lambda. So in electron volt, you need to divide it by electronic charge. So if you just put this value, that is the h is the Planck constant, c is the speed in the light in the free space, and lambda naught is the long wavelength, that is the maximum wavelength or in terms of minimum energy. E is the electronic charge. So if you put all these things, you will be get this value in electron volt. This is very simple, just using this formula. Next question. What are the momentum and the effective mass of a zero point 0.2 nanometer wavelength of photon? So this is the wavelength of photon. You need to find out momentum and effective mass. What is momentum? Momentum is E by c, or you can directly written as de Broglie wavelength, that is P equal to h by lambda. From the de Broglie hypothesis, that is the linear momentum is equal to h by lambda. Lambda is the wavelength associated with the waves. De Broglie hypothesis says, that is de Broglie hypothesis, which says that is the P equals to h by lambda. This is the Planck constant, and lambda is the and P is the linear momentum, right? So linear momentum, okay. So this is nothing but the particle property, and this is the wave property. So this relation actually relate to the wave property with the particle property, that is the dual nature of the particle is associated with this relation, okay. So using this relation, you just say that is P equals to h by lambda. H is the Planck constant, lambda is given, that is 0.2 nanometer. Nanometer to meter is multiplied by 10 to the power minus 9. So this is the momentum. Clear? And what will be the effective mass? You know P equals to m into c. Just like P equals to mv. V is the velocity here. The velocity of the photon is the speed of the light, that is the c. So just m equals to p by c, you will be get the effective mass of this photon. Next question. Next question says, in Millikan's experiment of photoelectric effect, the slope of the straight line obtained by the plotting cutoff voltage against the frequency of incident radiation was found this. So this is the slope taking E value, calculate the value of Planck constant. You know this relation of the photoelectric effect, that is the h nu equals to h nu naught plus E into Vs. Vs is the stopping potential, right? H nu is the incident energy, h nu naught, which is the work function or the minimum energy required to the electron jump from the metal to its surface, and this is the energy, excess energy, which actually behaves as a kinetic energy of the ejected electron. So if you rearrange that is h nu minus evs equals to h nu naught, so divided by this thing, you will be get this relation. You can see here this nu as a x and v as a y axis. So x by a plus y by b equals to 1. That is the intersecting equation of a straight line. So the slope will be like that. So the intersect will be nu naught, and this intersect will be minus h nu naught by e. The slope will be h nu naught by nu naught, that is the h by e, and this slope is given as like that. So the slope equals to this one. So h equals to slope into electronic charge. So if you just multiply this slope into electronic charge, you will be get the value of Planck constant. This will be the Planck constant obtained by this experiment. Next question. Next question says a photon of energy 110 kilo electron volt suffer 10% change in wavelength on being scattered by a stationary free electron. So the change in the photon, wavelength of the photon is 10%. Find the kinetic energy of the recoil electron. So just remember in the theoretical part, that is the wave incident in this rest electron, and this wave scattered, and this is the recoil electron. Okay, here says this lambda, this associate with lambda. If you write down the wavelength, this is lambda prime, and this is the lambda wavelength associated with the wave. So this lambda prime minus lambda by lambda into 100%, you will be get this 10%. Okay, so this is the 10%. Now you need to find out the kinetic energy. You know this relation shift, the frequency shift, nu prime equals to nu by 1 plus 2 alpha sine square phi by 2, that is phi, alpha equals to h nu by m naught c square. Okay, so this is can be written as like that. So lambda and nu is inversely proportional, so this lambda prime by lambda can be written as nu by nu prime. So from this relation, nu by nu prime is nothing but 1 plus 2 alpha sine square phi by 2. So just you will be getting this value. This is the this will be used in the expression. So the kinetic energy of the recoil electron is h nu into that one, and this value is right down here, just 1 by 10. If you put, you will be get 10 kilo electron volt. I think clear. Next question. Next question says X-ray of 100 XU, that is the unit of a length of wavelength, fall on a carbon scatter. The scattered radiation observed in a particular direction consists of this. So this is the lambda and this is the lambda prime. Find out the direction of scattered photon. So you need to find out this angle phi. So just using this relation, that is the wavelength change after Compton scattered, that is the put this value lambda prime is 112, and this is the 100, and 1 xu equals to 10 to the minus 13 meter. So if you put this value minus 13, is this correct? Yes. Okay, no problem. So if you put this value, and this is h, m naught is the mass of the electron, c is the speed of the light. So after putting this value, you will be get the phi value is 59.7 degrees centigrade. I did not get 30 degree centigrade. I did not know what is the problem, but I get this value from this relation. Okay, next question. Next question says a photon of energy each nu of is Compton scattered through an angle pi by 2. So this angle of scatter is pi by 2 of electron at a rest. The wavelength of scattered photon is twice that of the incident photon. That is the lambda prime is nothing but 2 lambda. So if you put this lambda prime equal to lambda plus h by mu naught 1 plus h m naught c 1 minus cos alpha. So if you put lambda prime equals to 2 alpha, you will be get lambda equal to h by mu naught c. So lambda is 3 by nu. So from here you will be get the value of nu. That is the frequency of photon. And the angle of recoil can be obtained from this relation. Actually, this relation in derived in theoretical class. You can go through the description wall, link are given there. So cot theta equal to 1 plus alpha tan phi by 2. So you will be get this, and you can see that is from here you will be get h nu by m naught c square equals to 1, which is nothing but alpha. So value of alpha is 1, so this is 2. You will be get this theta equal to cot inverse 2. Simple. Next question. Sorry. A photon is scattered by a stationary free electron of mass m naught. This is the mass m naught. Find the momentum of the incident photon if the energy of scattered photon is equal to the kinetic energy of the recoil electron with divergence angle 90 degree. Here says this angle is theta is 90 degree. Ek prime, that energy of the scattered photon and the electron will be equal, and you need to find out the momentum of this incident photon. So you can see that is h nu prime equals to ek equals to this, that is the energy of recoil electron is this, and this is nothing but the equal to h nu prime as the question says. So if you compare okay, this one, and you know the nu prime equals to like that, if you compare these two relation you will be get this value 2 alpha sine square 5 by 2 is 1, and the h nu equals to, that is energy of this incident photon will be h nu equal to this, and this value is 1, so you will be get 2 ek, and the momentum equals to h by lambda, so h nu by c, lambda equal to c by lambda, lambda equals to c by nu, so h nu by c, and h nu equals to 2 ek, and ek is nothing but m naught c square, because the kinetic energy actually the total rest energy of the electron, because initially this was a rest, so the m naught c square, so this is the answer. Next question. A photon with energy 0.46 mega electron volt is scattered at an angle of 120 degree by a free electron at rest. So this angle is 1 is 120 degree, and the h nu equals to 0.46 MeV. Find the energy of scattered photon. You need to find out this h nu prime and the energy of transfer electron, that is the kinetic energy of recoil electron. So h nu prime equals to h nu by this. Put this value. This alpha can be calculated h nu by m naught c square. H nu is given there 0.46 mega electron volt, mega 10 to the power 6, electron volt to joule 1.6 10 to the minus 19. That is the charge of electron is multiplied to electron volt converted to the joule. And the mass of the electron is 9.11 10 to the minus 31 kg, and c is the 3 into 10 to the power 8 meter per second. That is the speed of the light in free space. So if you put this value, all these things, you will be get the value of alpha equal to like that. So if you put this value of in this in that point, and that point, actually there is a missing of 2. I think okay, there is a missing of 2, that's why there is a problem. Okay, there is 2 and alpha sine alpha, okay, I correct these things, no problem. 2 and sine 5 by 2, that is sine 60 root 3 by 2, so you need to multiply with this with root 3. Okay, so this is 0.46 divided by 1 plus 0.8977 into root 3, you will be obtained, that is the 0.18. If you put this value, you will be obtained, I think there is no problem, this 2 to cancel out. If you multiply this root 3 with that one, if there is no error, this answer will be 0.18 mega electron volt. If this is 0.18, so this will be sorry, 0.46 minus 0.18, that is 0.28. This will be become 0.28 mega electron volt. Kindly check this thing is there is correct. If this is correct, so this will be the answer. Okay, so I think clear. If there is any doubt, you must comment in the comment box. Go to the next one. Next question says, a photon of energy h nu, this is a photon with energy h nu, Compton scattered through an angle alpha. This phi angle changes, here the question says this is alpha, so that the ratio of kinetic energy of recoil electron will be like that. The ratio of the kinetic energy to the recoil of the photon will be like that, where beta is these things. You can see this beta value h nu by m naught c square is noted as a alpha, so alpha is transformed into beta and phi is as a alpha in the general in this question compared to the general case. So nu prime equals to nu is the given is the relation which obtained in theoretical part. So h nu prime equals to h nu by 1 plus 2 beta 1 minus cos alpha, because this is a 2 sine square phi by 2 is nothing but 1 minus cos phi, but here phi is a alpha and alpha is the beta. Here the kinetic energy of recoil electron is the difference of this thing. So Ek by h nu equal to like that, h nu prime by h nu equals to this one. So this is the product. I think clear. If there is any doubt, you must comment in the comment box. So this is all about me. and this is my contact detail. You can connect with me with this Telegram channel. This is my online platform, and this is my YouTube channel details. Go to this channel, you will be get different physics related video with some mathematics like this session. If you learn something from this session, share this video to your friends so that he or she also get benefit from this video. And subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming videos. So take care. We'll meet you in the next video as soon as possible. Thank you.